Hello and welcome to our webinar on 10.5 segment lengths in a circles. This is the last webinar for this unit on circles, so hope you guys are watching it. A couple things that we need to know. These are two skills that we need to know before we go into this section. So the first one is to FOIL. And so FOIL is an acronym for first, outside, inside, last. And so if I multiply the first terms together, that would be 2x times x. There's my first. Then I add on my outside, which would be 2x times 5. That's outside. If we do my inside terms, that would be those guys right there, which would be 3 times x. And then my last terms are the 3 and the 5. And that is how FOIL is set up. That's the way we set up FOIL. A way to solve with it. And so if we combine like terms, we'll end up with what we have. We have 2x squared. If we multiply this together, we'll have 10x plus 3x plus 15, and this finally simplifies down to 2x squared plus 13x plus 15. There is another way to go about this that you can use, and it's similar to FOIL. It is actually what we call an area model. And the area model is very helpful for this, to multiply this together, because some people like it better than doing FOIL. And you'll see how it's related when I draw out this little box. Basically what I'm going to do is I'm going to find the area of each little square in here, and I have 2x plus 3, and that's my 2x plus 3 section, and then I have x plus 5 across the top. And so if I find the area of each little rectangle, I'm going to do my length times my width, which is 2x times x, which is 2x squared. If I take my height times my base of this one, it's going to be 2x times 5, which is 10x. Then if I want to find the area of this rectangle, it's going to be 3 by x, so it would be 3x. And then if I want to find the area of that rectangle, it's going to be 3 by 5, which is 15. And so you can see that it basically, after doing the area model, I end up with the red line there. And then by combining like terms, I get to the same thing. So you can do it either way, FOIL or the area model. Either way will work to multiply these out. Then you also need the quadratic formula, which is this formula over here. And so we need to multiply this out and talk about some of this stuff. So I'm going to drag the quadratic formula down. And so if I multiply this thing out, I'm going to end up with 144 equals x squared plus 6x when I distribute my x to both terms. So if I move the 144 across, I get 0 equals x squared plus 6x plus 144. Now, one thing that you need to understand when we're doing this problem is that there's a standard form for a quadratic equation, which is ax squared plus bx plus c. Well, that's where the a's, the b's, and the c's come from in this equation up here. And so the a is the term in front of the x squared, the b is the term in front of the x, and the c is just the constant. So up in this formula up here, that's where I'm getting these numbers from. And you'll notice that there's no number here in front of my x squared. We have to assume that there's a hidden 1 there, and that always happens whenever if you remember from algebra, that's what always happens. So if I want to use the quadratic formula to find out what x is, x will equal, and then I just follow the formula. Well, it says the opposite of b. Well, b is positive 6, so I'm going to use negative 6, plus or minus the square root, and so b squared, so I'm going to square 6, which is 36. Then I'm going to add or subtract 4 times a, which a is 1, and c happens to be this 144 over here. So that's all under the square root. And then I divide by 2 times a, and a is still 1, so I just plugged in everything. The only thing I kind of left out of this was that this was 6 squared, which is b squared, which is what went in there. So now if I just simplify underneath my, simplify as much as I can, I will get my answer. So I'm going to end up with x equals negative 6 plus or minus the square root, and so I'm going to have 36 minus, in this case, oh, oops, that should be a negative 144 up here in the problem. I messed up when I subtracted my 144 across the equal sign. So that should have been a minus 144, which changes this in here to a negative 144, and therefore 4 times 144 will give me a negative, let's see, 6 and 7 and 5. So it's positive 576 because a negative times a negative, and so if I combine, and then all of this is still over 2, and so if I keep simplifying this, I'll end up with, it looks like 612 underneath my square root, and I probably should get a calculator out to check this to make sure I'm doing it right, and then all of that will give me my two different answers. So let's get a calculator out. Find that, there we go. So when my calculator finishes opening up, we'll check our work, make sure we did it correctly. And so at this point, I had, what I'm checking is my 4 times 144, make sure I multiplied that correctly. Alright, 576, and then I'm going to add that to 36, gets me 612, okay. And so then if I take the square root of 612, I end up with that number. And so x will equal negative 6 plus or minus 24 point, what was that number? 24.7, we'll say, all over 2. So you have two answers for x. X is negative 6 plus 24.7 divided by 2, and x equals negative 6 minus 24.7 divided by 2. And so that would give me that will give me the two numbers to solve this quadratic formula. So you need to do this, you need to know how to do this. If you need to rewind this and watch it again, please do so, because you really have to be able to do this throughout the day. You'll see us do this. Okay, so moving along, so we got a couple definitions here. We want to put them in the order that we have over here. It says order the segments by their definition. So we're going to start with PS, so I know PS is up here at the top row. And so PS, if I look at it, it looks like it is a tangent segment, which is good to know, because it is tangent to the circle at an endpoint. So if I'm putting them in order, that's the way it's going to look. The next one they want me to use is PR. And PR is this whole segment right here. And you'll notice that it not only touches the circle, but it keeps going through the circle, so it looks like it is a secant. And so PR is a secant segment. And the reason is because one of the two intersection points are on the circle. So then we have PQ, which is my third one, and it is an external segment of PR. So let's check and see if we did those right. We did them all correct, so please make sure you get these down, because we're going to be talking about the internal, external secants and all that tangents all today. So then we have our first theorem, and it says if two chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So basically what it's saying is take the pieces inside, multiply them together, and it'll equal the pieces on the other side multiplied together. So EA times EB on the same line will equal EC times ED. That's our theorem. Make sure you get that down. So let's solve this problem. So we want to find out what ML and JK are, and you'll notice that it's the two segments are intersecting, so we're going to have to multiply these guys together. So if we take the two intersegments, x plus 2 times x plus 1, the two smaller segments, will equal x times x plus 4. So now you can see where the FOIL or the box method will come in handy. And I'm actually going to do the box method for the first part right here. If you want FOIL, that's fine, but you can do FOIL. I'm going to say x plus 2, and on the other side x plus 1. And so if I multiply to find the area of this rectangle, I get x squared. If I multiply to get the area of this rectangle, I get 1x. If I multiply to get the area of this rectangle, I get 2x. And then the area of this one would be 2. So multiplying this out gives me x squared. If I combine the diagonals here, I get 3x. And then plus 2 would give you be the multiplication of those together. Finally, on the other side, this is just distributing, taking x times both of my terms, which gives me x squared plus 4x. So now the whole idea is that I have to find x, so with this equal sign, I can subtract x squared across the equal sign. Hey, that's good. No quadratic formula necessary. The x squareds go away. I'm left with 3x plus 2 equals 4x. And if I move the smaller x across the equal sign by subtracting 3x, I get x equals 2. That's very good. Knowing that x equals 2, now I can find the length of ML. Well, if I put 2 in for x here, this piece up here is 4, and on the bottom, that piece would be 3. So if I can combine 4 and 3 together, ML has a length of 7. JK, knowing x is 2, that little piece is 2, this little piece is 2 plus 4 would be 6, and so 2 and 6 means that JK has to be 8. So that's what we were asked to do. Those were the lengths that we were trying to find, and I'm going to check the work down here just to make sure that we did it all correctly, and there you go. That's really what we're looking for. So then we have another theorem that says if we have two secants, basically lines that cross into the circle, that we will end up, if we take the piece outside and multiply it by the whole length of the secant, that will be equal to the piece outside times the whole length of the secant. And yes, you need to get these down in your notes, so pause it if you need to, but I'm going to move along. So then, what I'm going to do is I'm going to, so if we are to find the length of x in this one, we have, if you notice, pretty much you have to look and decide what it is, that we have two secants. And so the secant theorem says if we take the piece outside and multiply it by the whole length of the piece, which would be 15, 6 and 9, that's going to be equal to the piece outside times the whole length. And this is where it gets tricky. I have to add these guys together, and I get 5 plus x, or x plus 5. So now if I multiply 6 times 15, I end up with, what do I get, 90? And then I end up with, I have to distribute my 5 to both terms, and I get 25 plus 5x. So now I need to go ahead and solve this. If I subtract 25 across the equal sign, I end up with 5x equaling 65. And if I divide by 5, I believe I will get that x would be 13. And we could check and see if this works, because if I take 9 times 15, that should equal 5 times 13. And so 9 times 15 is 90. Wait, I did something. Oh, oops, this should be 18. There we go. So 9 times 15 is 90, and 5 times 18 is also 90, so we did it correctly. So my x value was 13, which is what I was looking for. And this I should go back and put well, this should be example 2, I believe. Let me go back and check. Sorry, guys. That was example 1. Yeah. Okay. So example 1. This is example 2. Ignore that number there. This is now example 3. And so now if I go ahead and find x, well, this is our first theorem that says if we take